morning, everyone.
Good morning, ma'am.
Okay, am I audible to you all?
Yes, ma'am.
Yes, ma'am.
Hmm. Okay, then let's start our lesson for today. So the next thing is we'll see how recovery will be done when a transaction fails. Okay, so this is again related to transaction. So we already know what is transaction and how transaction concurrency can be controlled. Means how we can control two or more transactions which is executing the same time in order to make our database consistent in all the states, in all the time, at all the time. Okay. So what is this recovery from failure? During the execution of a transaction, means we know that transaction, if it is executed, then the whole instruction that we have in the transaction should be executed. If it is even a single instruction is not executed, then all of them should not be executed, isn't it? So we think a transaction as a logical unit of instruction. So what will happen is, if during the execution of the transaction, a transaction might be having many instructions. A single transaction might be having many, like thousands of instructions in it. So it is going to take time and when a transaction is executing. So during the execution of this transaction, failure might occur. Okay, the transaction might fail at some point of time. So if such failure occurs, then how we are going to do the recovery from this failure? So we'll see those things here. Causes of failure. So it can be a system crash or transaction errors, or it may be due to viruses that we have in the system, or catastrophic failure, like it may be because of some catastrophic, like some natural calamities or whatever, or incorrect commands execution like this. Okay, like division by 0 or something like that. So if such thing occur, then the transaction is going to be failed. The execution of the transaction is going to fail. Okay, so for that, how the recovery will done? One such thing, one thing for a transaction, and you need to know is system log. So what is this system log? We can use the system log if recovery is required. Okay, so what is this system log? So when a transaction starts executing, a system log will be created. Okay, for that particular transaction. System log will be created for that particular transaction, which is going to have all the detailed information about the transaction, about that particular transaction. So for each transaction, a system log will be created. Okay, so even here, definition is given. You can see it. System file storing information about the start and end of each transaction and any updates which occur in the transaction. That means the system log of a transaction is going to have the details information about that transaction. Okay, can you see my screen? I think it is taking some time for loading. So can you see it? Can
Yes,
you
ma'am.
see?
Yes, ma'am. Actually, ma'am,
Okay.
it's a little bit lagging here.
Oh, yeah. I think it is because of my computer. But if you are having any confusion during my lecture, then you can tell me. Okay, now let us see what information it is going to gather. Inside the system log, means information is going to be stored for a transaction, isn't it? So what information is going to be stored there in the system log? So the log records are going to have start transaction. So if the transaction starts, then start transaction will be stored there in our system log, in that particular transaction system log. And then any read item, if read item operations take place, then read item information will be stored there, will be saved there in the system log. For same thing for write item also. For write item, many information needs to be there, like transaction ID, and then the item for which the writing operation is going to be done, all value of the item X, and then new value that is written by the transaction and for this item X. So all this information will be saved there in the system log. Okay, and commit T, abort T, checkpoint, whatever information, all this information will be saved in the system log. So if a commit executes for a transaction, then that commit will be stored in the system log. Okay, even if abort for a transaction, if transaction aborted, then what will happen? That information will also be stored in the system log. And what is this checkpoint? So if, as I told you, a transaction might comprise of many instructions, isn't it? So when we set the details information about a transaction, when the transaction is executing one instruction after another, what will happen is the information will be stored, will be shared, will be written there in the system log. Okay, and after some time during the execution of the transaction, checkpoints, we can have checkpoints in the system log. Okay, we can have checkpoints. So this checkpoint, what will happen is whenever we roll back or we redo or undo something, okay, if the transaction fails or if the transaction commit, then after commit, if the transaction fails, or before commit, if the transaction fails, then what will happen is undoing or redoing, we can do it till some particular time. Okay, because if the transaction is made up of many instructions, thousands of instructions, then and then at some point, if checkpoints are there, then might not require, the system might not require to undo all things or to redo all the things. So because of that, checkpoints will be stored there in the system log. Okay. So that is some few things that you need to know about recovery for a particular transaction. So recovery, how recovery will be done? So recovery means by using shadow paging we can do recovery, and by using redo we can do recovery, undo we can do recovery, and undo and redo it is going to be used in the default update and immediate update of transactions. Default update, immediate update, I have already briefly described the definition for default update and immediate update, isn't it? So anyone remember what is this default update and immediate update for a transaction? Anyone of you? Can you tell me what is default update? Say when a transaction is executing, after the execution of each and every instruction, the updation which is done by the instruction will directly affect the database at that point of time. So those updation is known as immediate update. Okay, those updation is known as immediate update. It doesn't wait for the commit execution of the commit instruction. Okay, so if a transaction is, if the database management system is using immediate update, then for each and every transaction, and when the instructions is executing, the updation will be done at that same point of time without waiting for the commit to execute. Okay, for default update, as the name suggests, also means immediate update. Immediate update means immediate updation will be done to the database. Okay, default update means it will wait for the commit. After commit, whatever instruction is executed means for the particular transaction, it will be updated to the database. Okay, it will wait for the commit. Okay, so that is known as default update. So those for default update, what we will do if the system is using default update and a failure occurs. So we'll see that. And then if the system is using immediate update, and then what recovery methods needs to be done, and in the case of failure, so those things we will see that one by one. The first one, what is this redo? So redo means, as the name says, it is very easy. Let us just read it out, and you will be able to understand. If a transaction crashes after commit, okay, after commit, remember this. When we need to do this redo, if the transaction crashes or if the transaction fails after commit, okay, after commit, if the transaction fails after commit, then only at that point of time we need this redo. Okay, so remember these 2 points. After commit and redo will means it needs to go together. So if a transaction crashes after commit, then the recovery manager may redo transactions, that is redoing all the operations of the transaction. Means it might be redoing all the operations of the transaction, or it might be redoing till a checkpoint. So I already told you what is this checkpoint, isn't it? So redo can be done only till a particular checkpoint also. So that is also possible. Okay. Then the recovery manager may redo transaction. So this is what is known as redo. And we need to do redo only if the transaction is committed. Okay. This involves examining a transaction for the log entry write item T, X, old value, new value, and setting the value of item X in the database to new value. Okay, so redoing what needs to be written is, if there is a write item for a particular transaction which crossed during the execution, if there is write item, okay, if there is write item instruction like this, then redoing means in the database what we need to do is the value for item X will be set to the new value. Okay, that because the transaction is already committed, isn't it? As it is already committed, it needs to change to the new value. Okay, so that is why the value of X will be set to the new value. That is written by the transaction T, which is fail after commit. Okay, so this is your redo. We can use this redo and the log entry to do what? To recover from the failure of a transaction. This is the first thing that we can that we can do in order to recover. Okay. The next one is by using undo. Again, we can use the log entry and undo in order to recover. So when this undo will be used, if the transaction crashes before commit. Okay. Already some of the instructions is executed, but it is not yet commit, and the transaction fails. Then what will happen? We need to undo. Okay. If a transaction crashes, then the recovery manager may undo transactions, that is, reverse the operations of a transaction. This involves examining a transaction for the log entry write item T, X, all value, new value. That means in the database, we will set the value of X to the all value. So this is known as undoing. Okay. And setting the value of item X in the database to all value. Okay. So transaction T has already written the value of X from all value to new value. Okay. So all value was overwritten by the new value by this particular transaction T, which failed before commit. Okay. So if such thing happens, then we need to undo, isn't it? So undoing, we will use the log entry for the particular transaction. We'll use the log entry, and what will happen is the item X needs to be, the value of the item X needs to be set to its all value. Okay. So this is known as undoing. So we already know how to recover from failure by using system log, and then by a redo process, and then the undo process. There are other things that we can use also. Okay. So one of those things is shadow paging. So we'll see shadow paging after some time. For the, now let us just see what is this default update and widget update in details. So we already have some idea about it. Let us just read it out. The first one is default update. This technique does not physically update the database on disks until the transaction has reached its commit point. See, this is the thing I told you. Before reaching commit, all transaction updates are recorded in the local transaction workspace. So there will be a workspace. Okay, so workspace. So whatever operations is done, whatever updation is done by the transaction, it will be saved to another space, another location, what is known as transaction workspace. Okay. If a transaction fails before reaching its commit point, it will not have changed the database in any way. So undo is not needed. Okay, so whatever updation is done by the transaction, it will be saved to another location which is known as the transaction workspace. Okay, and the database is not yet updated, isn't it? The database and the transaction haven't changed anything in the database. So if the transaction fails before reaching the commit point, then what will happen is undo. We do not need to do any undo because the transaction haven't changed anything to the database. So undoing is not necessary at that point of time. But what will happen is it may be necessary to redo the effect of the operations that are recorded in the local transaction workspace because their effect may not yet have been written in the database. Hence, the default update is also known as no undo redo algorithm. Okay, that means whatever updation is done by the transaction will be saved there in the transaction workspace, isn't it? It will be set in the transaction workspace. So if the transaction commits, okay, if the transaction commits and it fails, after commit it fails, and by the workspace we need to redo. Means it is not redo, but still we'll give the name redo. By using the workspace, we'll redo whatever updation that is done by this failed transaction in the database. Okay, so that is why the name of default update is also known as no undo or redo algorithm. Undo, we do not need this undo. Okay, but redo might be necessary at some point of time when the transaction fails after commit. Okay, so that is why default update type of this one transaction means this kind of updation is also known as no undo redo algorithm. Okay, so this is for default update. The opposite is the immediate update. Okay, so it is here you can see the other name of immediate update is undo or redo algorithm. Okay, so why it is given this name? Let us just read it out. In the immediate update, the database may be updated by some operations of a transaction before the transaction reaches its commit point. Okay. However, these operations are recorded in a log on disks before they are applied to the database, making recovery still possible. Okay. If a transaction fails to reach its commit point, the effect of this operation must be undone. Okay. That is, the transaction must be rolled back. Hence, we require both undo and redo. So that is why it is known as undo redo algorithm. Okay, so database means whenever transactions is executing, there might be some updation in the database. There might be some updation. If there is some write operation there in the transaction, then updation will be there in the database. Okay, before reaching its commit point and it fails. Then what will happen is, by using the log, system log, means by using the system log, we might still means by to use the undo process. Okay, undo process, because updation is already done in the database, isn't it? So undo process this might be required some point of time if the transaction fails before reaching commit point, and if the transaction fails after reaching the commit point. after reaching the commit point, then some of the instruction might not be directly affecting the database. So those instructions, for those instructions, the redo might be required. Okay. So because of that, immediate update type of this technique is also known as undo redo algorithm. Okay. So that is default update and immediate update. So by using undo and redo, we can recover transaction if it fails. Okay, so when to use this undo and when to use this redo depends on this particular system configuration and also how the transaction is failed, means at what point of time the transaction fails. So that is about undoing and redoing. So if means this is the particular technique by using which we can recover from the failure. Okay, so if you have any doubt here, then you can tell me, because we will start the next topic by using which recovery can also be done. Okay, so there is another algorithm by using which recovery can be done, and it is known as shadow paging. So let us see how this shadow paging works. So just some simple algorithms. Even after reading this whole thing, you will be able to understand it. So what is this shadow paging? What will happen is this one. There will be a shadow directory for every, when a transaction executes, and means for every database, what will happen is directory will be there. A directory will be there, and these directories are pointing to the data that we have in our database. Okay, you can say if this is a directory having a list of pointers. Okay, so list of pointers. You might remember this one, many data structures which use such type of this one organization, data organization. There might be some link table which contain the link of the data, and by using those links, and we can go directly to the data. So like that, there will be a directory in which we are, the system is going to store, or the pointers, or you can say links to the data items in our database. Okay, so this directory, for this directory, there will be a, if the shadow paging technique is used, then, and for such directory, this one, shadow directory will be created. A shadow directory will be created. So whenever a transaction updated data, whenever a transaction updated data, what will happen is means this for this new data will in a particular this one memory location. Okay, new data will be set there in the this one new location, and then the pointer for the new location will be set there in the shadow directory. Let us just okay. A directory with n entries is constructed where the ith entry points to the ith database space on the link. Okay. When the transaction began executing the current, when the transaction began executing, the current directory is copied into the shadow directory. So current directory which is having all these links to the data that we have in our database. Means this thing will be copied there in the shadow directory. Okay, and so shadow directory will be set on disk while current directory is used by the transaction. So when the transaction is executing, the transaction is use the current directory. Okay, but shadow directory will also be there, which is a copy of the current directory before the transaction starts executing. Remember this. Before the transaction starts executing, there will be create a shadow directory, and during the execution of the transaction, the current directory will be used, not the shadow directory. Shadow directory is never modified. This point. Shadow directory is never modified. When a writing of this okay, a new copy. When the write because write operation is to do operation in database, isn't it? So new copy of the modified database create. Okay, but the old copy of the page is not overwritten. Copy is also overwritten. So they will be okay. That is new copy and the old copy. And also
Ma'am, you are not
to
audible.
don't be and
Your,
yes.
your voice is breaking a lot. I think there is unstable network connection.
Now hear me now?
Nothing
Is
is
it
audible.
too breaking? Audible.
No, ma'am, not audible.
Working. Audible now. Am I audible?
Yes, ma'am, but voice is still breaking, ma'am. Like there is some low network.
Is it to you or to the other students also?
No, it's audible.
Okay, can you hear me now?
Yes, ma'am. Yes, ma'am. No, it's
Yes, ma'am. So here what is happening is database, whenever we modified something the data that we have in our database, then a new copy of the database paste. Okay, paste. You can there's one particular paste where data is stored. So copy of this paste will be free. Okay, along with the new data. Okay, so new page will be created and we are not going to override the old page. So the old page will also be there containing the old value of the data that the transactions is updated. So new page will be there and the old page will also be there. Okay, and the current directory is going to point to the new page. Okay, current directory is modified to point to the new dix block, whereas the shadow directory continues pointing to the whole modified dix block. Okay, current directory will point to the new dix block that is created because of this updation, and the shadow directory will continue pointing to the old dix. Okay, it will continue pointing to the old values. Okay, so if a transaction fails before commit, if the transaction fails, then current directory will be discarded. We need to do it. So doing anything, what will happen is we can just discard current directory. Okay, we can just discard the current directory, and the shadow directory will be used as the current directory. Okay, so shadow directory was pointing to the old values, isn't it? So they are pointing to the old values, and current directory is pointing to the new values that is updated. So if the transaction fails before commit, then the current directory will be discarded, which is pointing to the new values, and the set directory, which is continuing pointing to the old values, it will be used as the current directory. It will now become the current directory. Okay, so if this will be done only when the transaction fails before commit. But if the transaction commits or if the transaction fails after commit, then the shadow directory will be discarded. Okay, so here a particular thing that is happening is whenever a write operations is performed, then what will happen? A new disk means a new memory location will be created where the new value will be stored. Okay, new value will be stored, and the old value will still be there in the this one, all database spaces. Okay, and the new value will be point by either uh, by the link which is there in a current directory, and the old values will means it will still be pointing by the shadow directory. So if the transaction fails before commit, then the shadow directory will be used. Current directory will be discarded. And if the transaction commits or if it fails after commit, then the shadow directory will be discarded and the current directory will be used. Okay, so this is the point. This is the main thing about shadow. Do you understand what is happening here in shadow paging?
Yes, ma'am.
Okay, some few things that you need to remember about here. You need to remember what this current directory is doing and what the shadow directory is doing. And whenever a write operations is performed, on a new copy of the database space is created. And there will also be the old copy will also be there. Okay, it is not overwritten. But like that, it works. Means shadow directory will point to the old copy, and this one current directory will point to the new copy. And this old copy and new copy will be used if transaction commits, then the current directory will be used, okay, which is pointing to the new copy. And if the transaction fails before commit, then the shadow directory and the old copy will be used, discarding the new copy and the uh, current directory completely, and using the shadow directory as the current directory for the transaction, for the database. Okay. So this is how shadow paging used and how shadow paging helps the system to recover from any failure. Any doubt in recovery from failure? So these are all theories. It means if you want to know more about it, then means even uh, it means uh, this is the main thing you need to know. Okay, this is the main algorithm. So if you want to understand it better with more details information, then you can go through the reference book that I have given. Okay, so we have shadow paging, we have immediate update where undo and redo what is used if we need to recover from any failure, and we also have deferred update. So again, this here a redo operation might be required in order to recover from failure or anything happens. Okay, when the transaction is executing. So undo redo will you means that this undo and redo uh, will work along with the this one system lock. Okay. So in the next class, we'll see the last chapter that is remaining, and that is file organization. Okay, then let me take your attendance.